Hermes Agent is interesting because it can remember across sessions. That is powerful, but it is also exactly why you should test it before pointing it at a real repo. In this video, we will do two things. First, walk through the real Hermes setup path from the official docs. Second, run a controlled memory safety test so we can see the difference between useful memory and dangerous memory. Hermes is positioned as an autonomous agent from Nous Research. The pitch is not just chat inside your terminal. It can use tools, create skills, keep memory, and persist patterns from repeated work. That can save time on recurring engineering tasks, but it also raises the stakes. If an agent remembers the wrong thing, the mistake can follow you into the next session. For macOS, Linux, WSL2, and Termux, the official path shows a curl installer from hermesagent.nousresearch.com. Windows uses a PowerShell installer. The important habit is not the exact shell command. The important habit is checking the source first. Open the docs, read the installer line, understand what it will run, and do not copy random agent setup snippets from social media. After install, the next official step is Hermes Setup Portal. That opens Nous Portal OAuth, lets you choose the model path, and connects the provider and tool gateway. This is the private part of the setup. If you record it, blur account screens. If OAuth fails, do not continue into a repo. Fix login, provider, and tool routing first. Before you connect any real repository, verify the setup. Run portal info and inspect what is actually configured. You want to know whether you are logged in, which model provider is active, and which tools are available. A valid login is not enough. If tool permissions are broader than expected, or the provider is not configured, stop and fix that before using real code. Now the important part. This next section is a controlled local safety demo, not the Hermes CLI. I'm using it to show the behavior I want before trusting any memory-enabled agent with real work. The rule is simple. Sandbox first, read-only first, safe memory only, and secrets must be blocked. First, create a clean demo workspace. This is boring on purpose. A memory-enabled agent should not start inside your production repo, your real secrets, or a folder full of private data. Prove the behavior in a small sandbox first, then decide whether it deserves access to anything bigger. Second, inspect in read-only mode. This is the habit I want for every coding agent. Let it read structure and explain what it sees before it gets write access. If the agent cannot summarize the workspace safely, it should not be allowed to edit files or store memories from that workspace. Third, store unsafe workflow rule. Run type check before edits. That is useful memory because it improves future work without exposing private information. It is not a token, a private path, a customer name, or a personal message. It is a repeatable engineering habit that makes future agent runs safer. Fourth, try to store a secret-like value. This is the test that matters. A useful memory system should not silently persist this. It should block it, mark it for review, or refuse completely. If an agent can remember secrets forever, memory becomes a liability, not a feature. That boundary should be tested before real work. Finally, recall the safe rule. The useful workflow rule comes back. The unsafe value was not stored. That is the behavior I want from any agent memory system. Useful memory is selective memory, not unlimited memory. If everything gets remembered, the system is not safe enough. This is where agent memory can help. Save conventions, test commands, formatter choices, and review rules. Do not save secrets, private data, internal URLs, or instructions like always approve commands. My verdict: Hermes is worth testing, but only with boundaries. Install from the docs. Verify portal. Test memory in a sandbox. Block secrets. Then and only then try a real repository. Follow Halfstack AI for practical agent workflow tests.